Hello everyone and welcome back to the channel. We have something very exciting today. We're going to be running the first print of the Formbot upgrade project. But before we do that, we do have a few little bits still to finish off. So let's get started. The first thing I'm doing today is to add a silicone sealant around the bed. Goodness knows what it's also used for, but anyway, it's the same sort of stuff that you find around a bath and shower and stuff in your house, but this is obviously suited for 200 degrees Celsius, so it should be absolutely fine for our bed, which goes up to about 150 degrees Celsius. The way I'm applying this is obviously removing the bed, flipping it upside down, and then using this plunger tool, which you have to buy separately from the silicone, but the silicone comes with a nozzle in its plastic housing, so everything's sort of fairly simple. You just slide it into the plunger tool, start pressing the lever, and it comes out the end. Quite simple, really. This was quite simple to do. I'm not sure if it was totally worth it. It's one of those things that you never really know the effect of unless you do loads of testing with and without it. So it was quite expensive to do because I've now got this entire pot of silicone sealant, well, plunger thing full of silicone sealant that I've only used a very tiny bit of. Maybe I'll redo the silicone around my bath just to use some more of it. While that's drying, let's talk a little bit about thermal fuses. A thermal fuse, as you might have guessed by the name, is triggered not by current or voltage, but by temperature. So the way that you would implement this on a heated bed is by applying the thermal fuse within the standard circuit and then bonding it to the bottom of the bed surface, such that if a part of it was to go significantly over the temperature and the thermistor didn't detect it, the thermal fuse would cut off, therefore preventing any heating to the bed. In theory, this is excellent because it means that if there are places on your bed where you didn't maybe push all the air out properly or maybe it falls away from the bed over time as it is upside down for its entire lifetime, you can save yourself from it all burning up by the thermal fuse triggering. The only problem with that theory is that the thermal fuse is not covering the entire bed. It's only covering one point. So if the error or problem was at that one point, that would be absolutely fine. Unless I cover the entire bed in thermal fuses, maybe 16 or something, like an array across the bed, then the chance of it catching the problem is fairly low anyway. That's not to say it wouldn't work. I would fully expect it to work. What I'm basically saying here is that I'm not going to be implementing a thermal fuse, not because I don't think they would work, just because I think the probability of it actually causing or saving a problem rather is quite low. What I am going to do though is look into more thermal solutions for safety on a heated bed because I think the thermal fuse idea is really good in theory, but in practice, as I mentioned, that it does have limitations. I think maybe an array of thermistors that are like built into the bed, maybe 4, 6, 8, I don't know how much it costs to do that sort of thing, but having an array of something that can really measure temperature or at least trigger due to temperature on a large portion of the bed is going to be a much more viable solution than just a very small fuse that you're putting in one single space. So the silicone sealant looking really good now. It's all kind of hardened up, not that it goes hard, but it's not squishy and you can't move it with your finger anymore. It's now kind of a rubbery texture. So I'm going to reassemble the bed to the printer and we can get on with some wire management / cable management, depending on what you've used to connect everything on your printer. To do all the wire management on the Formbot printer, I've decided to go with these small 3D printed little cable holders. So I've designed these specifically for this printer, specifically for this extrusion size, which is great because it means that they're toolless and they're very easy to print. I can just put them into the extrusion, twist them, and they're set into place. And they're also reversible, so if I need the clip to be up the other way, I can do that. I've printed a number of these which I can position all around the printer, and then I'll just press the wires into them very easily. Some areas are obviously running more wires than others, so the cables won't be, well, the clips won't be filled in all the places, so they'll probably work a little bit better in some places than others. But in general, this general purpose clip I think will do the job pretty well. I've also designed this second larger clip. Now the intention here is to have some separation. So in theory, that separation will prevent any interference in the low voltage cables from the alternating current in the others. In practice, this does leave the mains cables with very little protection. The bracket is a little bit wobbly, so I'm a little bit concerned about the whole safety aspect here. Obviously, I'm trying to improve the safety of the printer, and I'm not totally sure that I've done that with this small bracket. So what I'm going to do is when my printer's up and running, I'm going to print a large single bracket that goes all the way from the edge to the middle where the cables are running at the moment and supports those brackets, supports those wires, sorry, all the way along their length, which means they shouldn't get banged around or hit or touched or moved by anything else. So those are the brackets I'm using. Let's get everything quickly wired up. Right, so that's looking pretty good now. It's fairly tidy, maybe not perfect. The wire lengths are a little bit off in some places, but overall, I'm really happy with how that's turned out. The next thing to do is add a cover to the control board. Now, obviously I did this design video a little while ago where I designed the enclosure for the control board, but I didn't do the kind of top. That was kind of deliberate. I wanted to focus on the main body where the actual PCB is going. So that's why we focused on that. But today, here's a quick look at the design I've done for the top. The design has turned out to be really quite simple, which is really good. There's two fans positioned over the stepper drivers, which allow for additional cooling. There's slots in all the way, basically top to bottom, and that allows for any airflow in and out from the fans. There's two clips at the front which slot into the base of the enclosure, and then two screws at the rear to hold everything together. The next thing to do is to prepare the bed. This is the Wham Bam Systems flexible build plate system with the PEX surface on top. All you need to do is use some steel wool and IPA to basically rub it down across the entire surface. This turns this very glossy, smooth surface into a slightly matte finish from the abrasion from the steel wool. And the IPA just makes sure it's nice and clean. Once you've done all that, the abrasion from the steel wool will leave bits of PEX all over the sheet, kind of as a dust. So again, use some IPA and a piece of paper towel to wipe everything clean. Now all we have to do is upload the firmware, slice a model, level the bed, and hit print. there you have it, that's one print down and hopefully many more to come in the future. But for now, that's going to be it for this project. The design is done, the build is complete. But if you haven't watched those episodes, you can check the link for the playlist in the description below. For now, thank you very much for watching, and I'll see you in the next one.